Hello?
Hello.
Hello, Sayed.
Good morning. Good evening.
Good evening, good morning. Yes. Oh, hello, Sushma. How are you?
Namaste, sir. I am fine.
Sushma,
How are you, sir?
thank you very much, Sushma, for the triple IT. Students came. You are very. They told they contacted you.
Yes, sir. They have contacted and I have coordinated with Dr. Dilip.
Thanks.
Sir.
I,
Yes, sir.
I know you will do it. That was a great.
Yes, sir.
Sayed, I had a long talk with
Yeah.
Kanwar
Yeah.
about
We are
symposium in
online. We are
Bangkok.
online. We are online. We will talk afterwards.
Okay, okay, okay. Oh, yeah, already recording. Mhm.
Online it is. Good morning, all of you. Namaskar. We will start this session. For those who are watching on YouTube, we are live there also. This is the third session we are conducting in the series of emerging technologies in agriculture. This was initiated since many students were keen to learn, especially in the domain of agriculture, not necessarily with engineering background. We had conducted 2 sessions earlier. The first session is a general introduction to what are the technologies, what technologies can do in agriculture in Asia. And we also gave introduction about machine learning and AI, very short introduction in the first session. Second session, we explained about convolutional neural network. What is a neural network? How the CNN is used. That's a machine language. How it is, machine learning, how it is used in agriculture. For example, disease detection, identification, sorting, all those examples we saw. Today, we are going to see a basic of electrical and electronics. Really basics, I'll go slowly so that all of you understand electricals and electronics, some background, so you can communicate with the experts for your needs and you can go ahead. This I found a big drawback in most of the places. Agriculture people are not aware of it. They are dependent without any background knowledge, especially on the IT or electronics people. This will help them to understand the basics and coordinate better. That is the objective of today's session. Today we will learn about basic of electrical, a bit of electronics, very simple. Then we'll also learn about sensors which are used in electronics. Some of the sensors are also used in agriculture, some of them not yet, but I think it will give a good idea for all of you to understand this. And tomorrow we have planned another session which will use the CNN model, which we developed in the second session, to show it on the web-based. We will use Google Colab to show tomorrow. Those sessions are very good for the students who want to work on the models. Most of the people, researchers, depend on IT department to develop or train the models. Actually speaking, nobody develops model. Even in the IT sections, only few companies in the world develop the models, what you call the ML models. Everybody uses the model to train them. So it'll be useful for you tomorrow's session also, who wants to learn, really work with AI. We'll show with the Google Colabs, one of them, that's for tomorrow. Today we will start, go ahead with the first straight away without spending much time, just a second. Okay, this is the third session. When we go, why we need, first let us see why we need electrical and electronics in agriculture. I will show you some of the examples. In equipments, we have tractors and wherever, whatever equipment, harvesters. We use a lot of equipments for controlling. For example, controlling the depth of, starting from depth of plowing and seeding, the control, and spraying, how much volume control. And in the tractor itself, a lot of attachments to control. They have a lot of communication control. They use electronics extensively for the last 4 decades in the world. In the West, it's very common. Every prime mover is equipped with these controls. In India, we don't have it yet. In Asia, we don't have much of them. And this is one thing we have to adopt if you want to really use the emerging technologies effectively. We cannot have without tools. So we have to understand this. Farm robots are getting popular in Asia also. and the drive systems, then how the robots are driven, how the motors are driven, what type of motors, we have to learn that. In robot control, we use something called BLDC. People don't know what is the name of it. I have seen in several places. I think we'll explain all those things slightly to know the basic principle of them, how they work, what is BLDC, how it works. We also use farm monitoring electronics, GIS application, drones, farm mapping, crop health with the drone, NDVI and NIR images. These are also full of electronics. Soil and water. I take generally about soil and water field. We use, a lot of people have tried to use soil moisture measurement, which are not very effective really. But then there's an attempt. We always believe we know the moisture, we can apply so much of water with it required. But we need much more data than only the moisture, current moisture measurement also. Water depth measurements, we don't have it here much in Asia. That means how much water is in the well, how much water is going to canal. I remember to 1.5 decades back, even for the Delhi water supply, what is the canal water coming, river water measurement was asked. I helped them to design that. So we don't have it in most of the canals when how much water is flowing, how to measure it. Runoff water measurements, we have seldom here actually successful in Asia. So how much runoff going? Rainfall, runoff. Only if we know it, we know how much is the water can be automatically recharged. And rainwater measurements also, for example, weather stations, rainwater measurements are very less. Actually, some private companies are using, and we have only probably taluka level data available to you. And that uses a lot of electronics. So we should understand them also. Resource application. In agriculture, we know we have resources, all the resources, for example, first of the input resources, water, fertilizer, seeds, how to do that. In water pumps are very popular. And I told already our efficiency is very low. Right now, around 25% only efficiency, whereas other countries have up to 70%, 60% efficiency. In that, we need pump getting damaged. What is the phase? What is under voltage? We will explain those things. We have to understand these basics so that we can communicate to electrical engineer what is the requirement. Because electrical engineers are not irrigation agriculture specialists knowing about the real pumps. Then irrigation automation also is very much lacking. If you ask somebody to apply this much amount of water, how will you do it? What is the automation technique? This is also purely electronics. Precision farming, we know as well, you know very well, aeroponics, hydroponics, vertical farming, all use a lot of sensors and electronics in them. In structural, we have greenhouse, polyhouse, automation requirement is there. In India, we spend a lot of money. In Asia also, polyhouses, controls is an issue even today. Logistics is another one area which the agriculture people have to bother about. Transportation is not like fruits and vegetables, not like any other material. Each one of material required, they are also requiring electronic sensing. Housing, very less work we have done. For example, we always say smallholder farms, but animal housing, fisheries gauges, for example, crabs gauges I have seen, the design, and poultry housing. These all require sensors and the structural. Farm processing, of course, extensively using electronics, dryers, grinders, and for the farm, pulp, powdering equipment, packing. This already, many of the big companies have taken over. But small farm-based, we require these machines, and they all use electrical. They use electrical and electronics, so we should understand the basics. Integrated farming, already I told, like poultry, animal. When the cow is coming heat, if we detect 1 month, the farmers can save the milk. And what is the produce? Logging, identification, farm lighting, and heating, safety equipment. Also use electrical. Storage of warehouse management, climate control, they also use electrical and electronics. Electric fences, we are already adopting in India. Extensively, other countries also for animals, for example, wild animals, intrusion. And the pest control also, electronic methods are available. Solar water pump management. This I put a generic one. This also we should know what type of pump, how to use, how to select, what is the advantage, disadvantage. Photovoltaic generation getting slowly popular. Whether it is affordable or not, different question, but it's getting popular. We should know about what is photovoltaics. That's purely electrical. Of course, communication systems for farm equipment accessories are very, very important. We don't have a system right now. We'll discuss about it. There are also electronics. And what is IoT in agriculture, what we talk. This is very required. Now, all these things we start now. These are requirements, so we have to learn electricity or electricals and electronics a background. So we see what is electricity. First, electricity is generated somewhere, then it's distributed. In that, for example, where distributed, you have alternate current, what you call AC. For example, in your house, mixie works on it. In farm, the pump works on alternate current, AC. Now, in that pump also, you have three-phase pump and single-phase pump. We should understand why three-phase I have to choose, why single-phase, what are the drawbacks, each one of them. You see, in real life also, we have everything. We cannot say this is best and this is not correct, good to use. It depends on the application we are using. Some things are good, something not. So we should try to understand both, then choose the appropriate thing for that application. Then we have drones, solar pump, they all use inverters, which means a lower voltage, lower pressure. You increase the pressure and use it. Those who understand hydraulics. In electrical, we call lower voltage, we increase the voltage and use it. Convert from energy from one form to another, one level to another, then use it. So this also we know. Another important factor is the losses, power factor. We have almost 15% losses in the farm power straight away going. So that means almost 1 or 2 power plants can be cut off in India. How to calculate the power? How to find out power are we using efficiently or not? I told about irrigation pumps, for example. Similarly, all other appliances are we using efficiently? Because we are wasting energy by creating more energy and we are wasting the energy in some other direction. We have to know protection systems. They are very important in agriculture. First, let us see, this is very important. I think I want you to get a grasp of what is electricity. It's like the Coco game, what you thought about child passing ball. Okay, this all of us know. Children sit and pass the ball around. Now, you see here, right-hand side, we know every atom has got electrons and what you call the protons. Electrons go in the valence orbit, they go in different orbit. Now, these atoms are very closely joined together, makes a molecule and makes any metal, material, your body, everything is made up of it. Now, take the first valence orbit, first left-hand side top, on the circle, one of the electron comes and pushes this electron out. So this electron will go to the next one, because otherwise this particular element will have more electrons, which cannot become non-stable form. So that's how the non-stable form comes. But they all want to be stable. Let's say a copper wire. In that one electron you remove from one of the atom, it goes to the next atom, it continues like that. So that is how the flow of the electrons happen. Now, question comes to me, who will make the first electron to move? You tell me that. Yes, there is something required to move the first atom, first electron out, and then it continues the process. But the electrons cannot be lost. So you have to give back the electron again to that atom back. And that makes a closed loop cycle, like left-hand side you see. It has to be closed loop cycle. Imagine each one is an electron he's passing and everything is going through it. So this fellow will give it, he cannot keep the electron, he give to next guy, like that it goes. This is what electricity basically. There is nothing happens, you just move the electrons from one to another. You can move it almost in every material, okay? Every material you can move it. But some materials are, they say they're resistant to move. No, if you give me, I will not take it from you. I will not pass it on to the next person. And somebody says, excellent, I am very generous. You give me any amount, I'll pass on to the next guy. So this is the difference comes electronics, what do you call. So we'll go to the next one. Who is the force to move the first electron? How the first electron is moved? By magnetic forces. If you bring a magnet, that will move electron. This is a natural, okay? Chemical, you make chemical reaction, it will move electron from one place to another. And that is the example of batteries, for example. You give a light, that will move the electron. And that is photovoltaic cells. You make vibration, that will move also. The vibration energy itself will move the electrons. Like, for example, piezo sensors we have. Like you must have read in China and or in Europe also, they bury on the road some small sensors type. So when the cars go, because of the vibration, they charge again the electricity back again. So this is also the new technique which is coming up to charge from the vibrations what you make generate electricity. Heat also will generate electricity, will try to move the atoms. So when the atom moves, the question is when the electrons, atom instead of atoms, I would put the electrons is the correct word. I'm sorry for it. Electrons, when they move, okay, I move through magnetism, but the movement creates also heat, light, all this stuff on chemical reaction. So this energy of moving one electron can create lot of other sources of a form of energy. For example, a bulb, a tungsten bulb. Olden days, you must have seen 20-watt bulb, 40-watt bulb with a filament inside. Okay, this filament inside, you will see it gives light, but it's also when you touch the bulb, it's very hot. Actually, most of the energy is wasted in heat rather than in light. So that is the tungsten is a very high resistive element. That is why it produces the light. It has been very, very, very thin form. If you see the old bulb, you will see that. The long one, but very thin one. And that is the tungsten, how it works with the heat. And so everyone generates the same way. Now we come to electricity, electromagnetism, we know it. Hydroelectric, that is a movement. Also we can generate electricity. Photovoltaic, we can do. Hydrogen cells now. Hydrogen cells also now generate. This is the recent in the last 30 years probably. And last 10 years, like I remember, India also has hydrogen engine, but we don't produce hydrogen. Producing hydrogen is another issue we have to see, but hydrogen cells are going to be one of the solution for the future of, let us say, a decade or two. Now, steam turbines powered by gas or coal, also this again. Now, normally when you see, for example, power station, I generate power, lot of electrons being moved. How will I transport it from one place to another? So I use a very high voltage. We'll come back to this voltage to understand afterwards. Very high voltage. Example, for example, house, for example, in India or Asia, mostly you use 220, 240 volts. Whereas in US, you use 110, and in France also use 110 volts. Okay, that's in the house electricity. In the farm, when you go, we have a 3-phase, we have a single phase. So normally a 3-phase, when you come to Asian size style, it is 440 volts. That's double of the single phase. We will see that also later how it is. But the high voltage means I can pump lot of electricity, electrons through a thin wire. Otherwise, to pass that, you also require very fast. When I pass that, the voltage is speed, how fast I'm doing. So much pressure when I push the electrons. Even a thin wire can pass much more electrons compared to slow speed. We require a thick wire. So that is the main reason why we use high voltages. One of the reasons why 220 volts is used in Asia and Europe, some parts, because of this, they use thinner wires compared to 110 volts in US and France. If you go there and you see the lines are very thick in US and France, all the electrical carrying wires, because they require double the thickness almost of what is used in Asia. So high tension lines, 3,000 volt, 4,000 volts they're using, and that will be reduced to lower levels to use it. So this is what we see a lot of transformer stations in the farm everywhere there. If you understand this much, okay, that's why the power grid means one place, one of the power generation comes more electrons, another place no electrons pass on, some gives some more, divert them, each one of them. There's a distribution power grids which are using. So the design of power grid, so one grid fails, it can fail all the system because it will overload the particular other system also. Nowadays, they are reduced very much. This power grids, there are a lot of excellent work in switching power one to another. But even last year, I think we saw in US also power grid failure and full darkness came. Localist photovoltaic generation and grid connectivity. This has become very popular, especially in India also. We saw a lot of industries in I think probably a decade time now. They put solar cells and they pump the electricity to the grid, to the MSEB or whatever the state electricity board. And they get the power from state electricity board. I think normally around 5 years you get the money back, and then it's almost electricity is free for you when you use this. So you should understand what type of grid connectivity for the farm required. Now you see here, I will try to show you what is the left side first. See before the image, you see left side, there's a voltage. You see, what is alternate current? Alternate current is electronic is going one direction, then reverse direction. How many times like reverses? Let's say 50 times in a second. Why it is happening? Okay, see here, right side, there is a image which is rotating. You will see the arrow mark. There are 3 status, they call 3 coils are coming. These 3 coils are the 3 phase. Okay. So normally RYB they call. Okay. This RYB phases. Now you see the direction, it shows an arrow. I think you can all see that. It goes depending on the magnet, center magnet, how it's rotating, the direction of the flow of the electron changes. Now in this image, you will see all the 3, we use 3 coils. So when I rotate the center part magnet, I will get electricity flowing in the 3 of the coils. So I got 3 phases. I mean, 3 sources of generation I have. This I can use all 3 electrons at one place, like a 3-phase pump, or individually I can use them for lighting, for example, like that also. You see, it's like principle is very simple. Why 3 they put? You see, bottom mode image shows you 3% try to rotate a wheel instead of 1%. So you will understand now 3% trying to rotate a wheel will be much better. Pressure correct place given when it comes, he rotates 3 of the persons, gives a movement, than a single person. A question comes as why not 4 then? Why only 3? Yes, 4 also done. When we come to BLDC design, you will see easily 4 phase are used instead of 3 phase. But why 3 phase used? It has been designed from the beginning. It found those days economically viable and good. Now, one more question comes to a picture. You see, in Asia, we use normally 50 hertz. 50 times the electrons move forward and reverse 50 times in a second. Whereas in US, it is 60 times a second, 60 hertz. So why we need 50 hertz and 60 hertz? This is to do with eye, human eye. Very first, when they made the electricity, it's for light. So if you make it only 10 times electron moving, it will flicker because your eyes can take 50 hertz. 50 to 60 hertz is what you see, your eyes can see. That's how the movie, when they made also, all these movies have 50 hertz. You rotate at that speed of the images, then becomes a running movie or movie happens. So this is because of a human eye only. This has been selected long back and it remains as it is. Now, if you ask me, is the same frequency used now in other things? Yes, general electricity, yes, we are using. But for our BLDC motors, like robots, all the stuff, we are using higher frequency because we generate that electricity in a different method. So we use a higher frequency that is for our other fine application like CNC machines, like BLDC motors, all we use higher frequency. But general agricultural application, you will find this is a 3-phase. So you be clear about 3-phase and single phase. Single phase is only one coil and 3-phase is all the 3 are used. This is very important because we use the pumps, we use 3-phase pumps and single phase pumps. What are the advantage and drawbacks of a single phase and 3-phase? 3-phase pump, as you know, is efficient, but it's more expensive to make. The same reversal, right now is the generation, for example, the reversal will become a motor. When you pass the current, it rotates the center magnet. So this becomes a reversal process. A generator and a motor is exactly similar. You reverse that. The design is slightly different inside. We don't worry about it. But I think that is the basic principle you understand. So you see, it is very effective. So 3-phase is always cheaper also to use than a single phase. But the problem when you design with 3-phase, if one phase comes off, it's absent, your motor winding other will get damaged, will not work properly. So you have to have all the 3-phase. 3-phase electricity throughout Asia also is much cheaper than getting a single phase. Because generation happens like this with 3 of the coils that generate from the generating place and transmit. So that is how we try to use always 3-phase and single phase. Now, we'll come to the question of why electrons must go back and forth. Because it's circular. The generation is circular. But linear, like a battery, yes, we also use it. We'll come to the next one to understand what is the direct current. The first, before that, in the alternate current, we use a lot of pumps. They are called pumps, use coils, like you saw, the motors, they have coil. So whenever the coil is there, you know the inertia, I think you all know, some of you know about inertia in schools. To starting pressure is there, stopping pressure is there, depending on the load. So what happens? Voltage, I showed you, voltage goes on increasing. Like we saw in the previous diagram, I'll go back to previous diagram. You see here the arrow, you see here arrow mark goes one direction, then starts coming in the other direction. Okay. So it will start moving the next direction. So this is the, what you call the, how the voltage goes up and then low here. So direction is positive here, direction is negative here. So that is how the alternate current. Similar way, current also, this is only, not only voltage. Voltage is the pressure, current is the flow rate. If you know in hydraulics, remember that very well. Like water pipe, you can see what is the pressure coming is the voltage, and current is the, what is the flow rate, how many liters per minute. That is the current. Now we have some of the problem is voltage comes ahead before the current can be supplied because of the heavy load. And this is called loss. When this happens, normally in inductive loads, like pumps, motors are using pumps are using motors. So they have a lot of induction problem. In that the losses are very high. So this is the biggest problem. I told you we are already losing at least 15% of the farm electricity energy because of these losses. How to correct them? It's easy to correct them. At each pump, motor, for example, you're using a motor for a pump, you put capacitor bank that will hold the current for a while, for a very short time, for a while, so that it stores the current for a little bit time. When the current is lagging, it will give the supply. It's like a small capacitor bank, means a small storage you keep for the electrons that will supply it. That will improve the efficiency to 15%. To demonstrate this, very simple, is a beer mug. I think you can see the beer foam comes. Foams is the waste. Actually, what you utilize is the beer down. Total is what the bill you pay for it. So that becomes actually is beer mug. Foam we written there just for example to you to understand easily. This last power is in where it goes. The power cannot be destroyed. Okay, so energy can never be destroyed. So it becomes a heat or vibration, and that's how it becomes your motors. Everything becomes hot, or a lot of vibration happens. This is one of the reasons. So we have to see that every motor has a capacitor bank. That much agriculture people will see to it. We can save 15% of energy in India, in every farm. You guarantee there is a capacitor bank. It's very cheap. Capacitors are in the motors they are using. That's all we require to do. And what they did, IIT Bombay has done the work, and the World Bank. They have put this capacitor bank on the farm pole, power pole also. So this also will help you. Asia is very important problem. We have to correct the power factor. This is called power factor. Now, direct current. Direct current is only one direction the current will flow. In one direction current flows means most of the electrons use only one direction. Okay. Now, DC motors, old systems all use DC motors. DC motors are very good, speed control, very easy, but they are not very efficient. So nowadays you have most of them use only AC motors. They use DC, convert it to AC into multiple phases, and then run it to be more efficient. But battery powered systems, tractors, they also convert DC to AC and use it. Inverters, all the inverters, brushless DC motor, that's called BLDC. Because DC motor require brushes. Because to rotate from unidirectional electron flow, you require, when it rotates half, you have to change the polarity. So you use brushes. I will not explain this. those who are interested, they can read. Because whatever I'm explaining to you is already available for decades. Only I'm trying to make it simple for you to understand. So, but BLDC motors uses the AC principle. It converts from DC to AC, like in the picture I showed you with the 3-phase rotating. That's how it's doing. Instead of 3-phase, sometimes use 4-phase. Very rare cases I've seen more than 4 phases also used. For that, you use a higher frequency instead of 50 hertz. You use in several kilohertz. Sometimes it goes up to 200 kilohertz also, certain applications. Now, how to measure the current? Power measurement is important even in the form. Just basic principle. One is just put a resistive. Yes, resistor means it resists to the flow of electron. Okay, a resistor is like a pipe. It just resists the flow of electrons. It will pass the electrons, it will resist a bit. So it will not pass very fast, it will pass slow. So how much it reducing that you measure it. That is one way. It's used in, for example, drones, robots, all of them are shunt BLDC motors. They use a shunt. They call shunt a resistor. Second one is a current transformer, which are used in high loads. Like solar pump power, how much comes? It uses a current transformer, CT they call. Very simple coil is there, and your electricity is passing through a wire here down. Center is the electricity passing. Center is the electricity passing. And this outside coil, because magnetic core, it picks up small amount of electricity. So because electricity is flowing this direction, there is some more electricity generated outside. This outside, how much distance between them? Could be 2-3 centimeters also. There's no problem. It can be. So it generates small voltage. So you measure this and you know how much current is going. So you actually relate the current flow in the conductor with outside you generate a relative voltage slightly. They are almost linear. They are available. This is extensively used for all the agricultural purposes also. There are important, many places I saw, we call, even the home, we call the electrician for repair and stuff like that. We should understand some basic of it. Because it really, agriculture, farm, this is a big problem. They take some wire and connect. I myself have seen. We should understand fuses, different type of fuses are available. Fuses are also resistors. But when more current is coming, it will break it. So your circuit is broken, so it's not damaging your device. So fuses are important. There are different type of fuses, and we'll see that in the next slide. One more thing in agriculture, very important, is lightning. Lightning today, these circuits, don't worry about it. Only right side you see it. Lightning arrestor. Because when you lay the cables down, see, lightning comes and hits anywhere, maybe 5 kilometers far away. Normally, it's around 1 to 2 kilometers range where you will get affected. This is this is thumb rule only, not, I have seen lightning affected in Ludhiana, one of the farm, several hundred acres farm. I have seen it, lightning affected the whole of the sensors, whatever, in the farm. So how to know lightning effects is very difficult to predict. Very difficult. Even lightning hit today, the device may work for another 2 weeks, 3 weeks and come off. So very difficult to find out lightning, how it attacks. And there is no really difficult to predict. So what we can do, we use a gas discharge tubes. These are commonly used. So for example, you use your irrigation, use for any sensing. Remember that word, gas discharge tubes or GDS, GTD, they're used or not. You, as an agriculture, you must know, have you protected for lightning? That is what I want to say in this. And the electrical fellow will give you automatically. This is like a gas GDT is a very simple. You see right hand side, the picture is there, right hand corner, and that is a small picture. That is how it looks like. It's not very big, hardly about 10 mm or 20 mm diameter and length of about 30 mm. So that is about the size, but that can solve all your problem of lightning. Protection systems, I will just say the names to you here because MCB, okay, there is a miniature circuit breaker. Don't worry about diagram. Circuit breaker has to put in every single phase of it and also neutral. You have 3 phases and 1 neutral. Neutral is the wire which can commonly carry all of them. But remember, RYB 3 phases, they are independent. Power is taken from the same line as well as given. So neutral wire, you cannot pass so much current, but you can pass on the phase. That's the reason three-phase is more effective. It can pass a lot of current. Single phase, you require neutral also same size as one of the phase size. So three-phase, that much thickness, you cannot make a neutral. So neutral is normally used for simple household applications. A mixie, whatever, fridge, all the stuff is used normal single phase. Lighting, it is used. So don't use it mainly in the farm application. It's expensive, works out to you, and plus not very efficient. Now you have the circuit breakers, MCCB, protection of ELCB is earth leakage current, RCCB is residual current. I will not explain. These safety systems which are used. If your wire somewhere touches ground or goes somewhere else, somewhere you detect and it breaks automatically. So remember the word whenever you install. Have you put MCCB? Have you put RCCB is better in agriculture than ELCB. ELCB is used mainly in houses, old items. This is the old technique. RCCB is the latest in the last, let's say, 15, 20 years. It's slightly expensive there, ELC, earth leakage or residual current. These two are the difference. Those who look detailed, but I think RCCB is there very safe for you. Remember that much, note it down. Let's go to a little bit, about 10 minutes, 5 minutes, we learn about basic of electronic, because you will see tomorrow, you'll see different senses, how it is, you must know basic. One is called in electrons is resistor. We use a resistor. A resistor is a pipe. This will reduce the flow of electron. So whenever you put resistor, it will reduce the amount of electrons going through or the amount of current flows through it. So you want to reduce the current, you must use a resistor. Second is inductor. Inductor is a wonder. Same look like a wire only, but wound like a coil. So we call inductor. What is the advantage of this is, to understand this, wire, when the current goes around the wire, when the electron flows through a wire, around the wire, it creates magnetism. I told you earlier also, you remember one form of energy, magnetism pushes the electron, but the electron movement also will create magnetism, and it will create heat, it can create light, it can create chemical reaction. So when the electron passes through any conductor, any of the wire or anywhere electron passes, it generates a magnetism around that. So you make the coil of the same wire. So when you reverse the flow, like alternate current, that will reduce automatically the amount of current flow. So wherever, see, resistor limits the current flow, but always constant. We know a resistor puts current only this much, it will send, it will block otherwise. Whereas inductor, I can vary that. It will vary based on the frequency. So 50 hertz I'm using, I can make it to give least resistance. With 500 hertz when I use it, I want to give maximum resistance. I can design that with some other component like capacitor like that. So this is very important. We are using already in our choke, lighting, everywhere. So this just idea for you. Indexed is induced resistance. Very simple. Induced resistance is inductance, which induces the frequency of electron change. Capacitance, I think it's a small storage place. I told you we have to know this in relation to pump, motor ka, how to save the power factor. Okay, now complex part is over. Now easier part we go through. We have to reduce transformers. This is very something we use everywhere. Transformers, actually higher voltage, it reduces the lower voltage. This is important for transformers. We use everywhere. They are very reliable. They are working quite well also. Transformer is one of the way to reduce the voltage. For example, you are getting 220 volts from a house or anything. Your device requires less. How to make it less? There are something called semiconductors. Okay, I will not explain all these things. Semiconductors. Resistors will conduct, they give resistance. But semiconductors they will do whenever they want something. It's a semi, actually. Like, what do you call it? They're not stable. They think they will do what they want. You can design the semiconductors only conduct on certain conditions. For example, if the electron flow too much is there, it will stop it. Or electrons left side is too much accumulated than the right side, then it will conduct it opposite direction also. So like they are the different type of what you call the diodes. Diodes are the basic ones. I know I learned it before 60 years in my radio. In my radios, what we had in the home those days, we used diodes. Diodes are the first invention. You must remember just diode because they're used in many places in farm also. For example, when you connect a solenoid, you must see this, is there a diode or not? You must ask the guy. Otherwise, the solenoid will blow, your electronic will blow. A simple thing, many electrical engineers also forget it to put it. So you must remember diode is semiconductor, so we need it, that's all. Another one, a component is transistors. I will not go into this. There are two types of transistors we use. This is to amplify the current. And this is something important you must know, MOSFET, the word of transistor, MOSFET. MOSFET is the one used for BLDC or all your motor controls, drones, everywhere. So your MOSFET is a very good compared to transistor usage, and MOSFET has got a limitation. You must know the word only. Power supplies. This is important we use in electrical equipment. One is the power supply linear regulator. Second is a SMPS. This, all your adapters, everything, switch mode power supply. They are very efficient, small area. They use a technique of creating high frequency and switching off, they create power supply. So you must read about SMPS. Most of the application SMPS can be used in agriculture, but sometimes you require a transformer to use. You cannot, because stability required, sometimes you have to use transformer. Most of the time SMPS are quite cheap and they're used already. Isolation circuits are very important in agriculture again. When you touch an appliance, you get a shock. Same way isolation is important in agriculture when you connect sensors to your devices. So you must ask the guy whether he has isolation possibility for connecting field sensors or whatever field electronics, anything is important, isolation. Now, isolation, one of them is input. Any input you're giving a switch or something, you must have optically isolated. They're called optocouplers. So you must have an optically isolated system, not by electrical wire. With the light, it is actually transmitting the signal. This is the safest in most of the agriculture when you want to use. Try to see whether you have opto-isolators used in the devices. Then the failure will be almost nil. Now, another thing is many of the signals we get in agriculture are analog. They are varying type, not in digital numbers. To convert, we call analog digital converter. This is used in almost all the equipments we are using in agriculture. There are different, you must know there are different types of them available. Okay, there are dual slope, successive evaporation, sigma, delta, and depending on the resolution, that means whether you have 16-bit resolution, 24-bit resolution. What is 16-bit resolution? Steps are 65,000 steps. What is the 8-bit resolution? 256 steps. So that is all. What is the input value? How much in digital form you can represent? So this all you have to learn when you use any analog word comes. For example, temperature sensor is analog, pressure is analog. We'll come to this later this session. All these things you will know, you have to know, ask about first which type they're using and which resolution, what is the speed of conversion. This, if you don't know, whoever supplies you machine in agriculture, research lab or whatever may be, you'll be finally sitting in the fool's paradise because he will make money and go away because you don't know the basics of it. So I would request all of you to see, it's used everywhere, pressure, level, sunlight, whatever measurement analog is used. So you must know the basic 3 types. I can explain afterwards if you want questions. When you ask me, then I'll explain this to you. There are different type of displays. I think you all know. You have to choose what display you want. So many type of display, OLEDs, so many are there. Different type of switches are available. Capacitive, membrane switch, cable lock switch. Correct switches must be used in agriculture. This is one of the big challenge, especially in prime movers, tractors and all. What type of switch actuation required? Which select? So it's I would say spend I think spend the correct amount of money and to get the really good actuators because they are the one which last long. Relays are also used heavily in agriculture. So relays are mechanical devices where it make contact between two. For example, to start a small pump, you use a relay. One of the possibilities to use a relay. So you must understand what are the different type of relay. Relays can be used for direct current or alternate current. And relays also, you have solid state relay, which uses only for alternate current. And there are drawbacks, advantage, both of them. when the case comes, you ask them. LEDs, all of you know. Solenoid valves are very heavily used in agriculture. There are different type of solenoid valves. Normal solenoid valves on the left side, corner, top, and you have the hydraulic solenoid valves used for irrigation. See here, the valves, solenoid valves means when you give power, it will cut off. Or when you give the another side power, it will turn on. This is one thing of the solenoid valves. There are latch solenoid valves. You give a pulse, it will latch to on state. Again, give a pulse, it will latch to off state. So this is used mainly on when you want to use solar panels for irrigation control. We use this, and this normal valves we use, normal solenoids we use when we have real power availability. For example, NPK mixing chambers, you want to put there 3 volts, 4 volts, you can use this also. Motors, you must understand the motors are very heavily used in robots, every electronic. You must understand the more different type of motors are there. Induction motor is AC motor, stepper motor, DC motor. So, and BLDC motor. These type of motors are available. Which motor you want to use it, you have to read about them. Now let's go to sensors for another 5-10 minutes maximum. And sensors, temperature sensors, these are heavily used in agriculture. And this, for example, RTD is one of the sensors, thermistor, thermocouple. These 3, I think many of you might be knowing, or you must read about it. Thermistor gives the least accuracy, but most of the time it's okay. It's good enough for us to use. Your air conditioner use the thermistor, for example. They give plus minus 1 degrees, plus minus 2 degrees sometimes. That's more than enough for most of the agricultural purposes. RTD is the very accurate, it gives you very accurate measurement, you can make the temperature. But high temperatures, when you go for over very high temperature, use thermocouple. Thermocouple is not very accurate, but it goes high temperature range. Temperature range is very high, from minus to plus we can go. And it requires a little bit of skill to use which type. This actually uses the principle of 2 metals joined together and put in heat, whatever heat or cold, it will generate that much electricity. That is the principle of thermocouples. So these 3, you must refresh it. And there are a lot of details you have available. I will share with this PDF with you. Then you have the sensors, temperature sensors. What do you call the semiconductor-based temperature sensors available. Left side, both of them. You have an infrared type of sensors also available for temperature. You have temperature with latest technology, what we have with the capacitance based also available. And you use a lot of gas sensors. For example, I use for the onion storage. We tried with the different gas sensors. For example, when you want to, whatever gas is released by methane released by paddy fields, or whatever you want to measure, something like that. And polyhouses, you want to know how much is the gases. These sensors are readily available. You must know what sensors are available, what accuracy they are there. So you have to refresh, you can find out easily all the sensors, almost all type of gases you are getting. But remember, certain gases like CO2 sensors, they don't last very long. They hardly for a year or 2, then you have to throw them out to get a better accuracy. CO is easier. CO2 is a bit expensive to make it. So you must know the difference. I mean, which sensor, how much reliability, how much accuracy really you want. Most of the agriculture, we don't require very high accurate. Even 10% accuracy, 20% deviation is okay most of the time. So we have to choose that type of sensor for that particular application. One more thing is using in sensor is gas sensors. Important is the calibration. They go off really very quickly. Some of them, like CO2 sensors, you have to calibrate every 15 days. Otherwise, the calibration goes off. So that you have to be careful, read about it before blaming it on the supplier or something, the technology. Now you have air quality. Now you have PM 2.5, PM1. They use 2 techniques. Actually, you should not get confused. Of course, 3 rather. One is chemical based, which are time period based, 2 years, 3 years. Another one is with the infrared, and third one is with the laser. Now, laser ones are coming to the cost of maybe 4,000 rupees. Good ones, 5,000 rupees up to that. Very good one. And then normal ones, 1,500, 2,000. See, this is used also in the farm to measure the burning issue. How much, what is the air quality in the farm outside? You can put the air quality because it measures in a really very small 2 micrometers. 2.5 is 2.5 micron, 1.0. And you can measure what is the size of particle, how many particles are there. Okay, this is also available to you. So these are recently used in all the building construction sites also. They are not accurate, but agriculture very important to know the air quality. You can use this. They are not expensive. You must be aware of them. You can use it. You have motion sensors, which we use in agriculture, all the places, motion sensors. After interpret, we have also LIDAR sensors. The laser. Radar is different and LIDAR is light, radar with radio wave. These are used in all the drones or using LIDAR sensors. How many of us try to understand LIDAR sensors? So these sensors I'll explain sometime detail when you ask. Now we'll ask the questions to you. Who are interested, we'll explain those individually. Everything will take 15-20 minutes to understand each one principle, how to select it. You have distance and motion sensor, ultrasonic, used effectively for spraying also in many places. Either ultrasonic or LIDAR. They use any one of the technique to find out where the real leaves or tree is there and where there is a gap, and when to start the jet of spraying and when to stop it. Proximity sensors are used in every agriculture equipment. You have revolution measurement also, you have a lot of them. Hall effect, for example, weather station. Olden days were to put a switch. Nowadays it's all with the Hall effect. You can measure everything. I think so many things are we have to know. Optical. These are actually sensors. Strain gauges. All of you know how to measure a load, a pressure, whatever it is there. Strain gauges are available. Torque measurements also is required in agricultural prime movers, especially, or any of the equipment. How much torque is required to move. Then your flow sensors are heavily used. Okay. Now, many of us, we don't know how much water is really given for irrigation also. So now, because nobody works on flow sensor development for it. In India, I have not seen any of the institute working on flow sensor measurement. I remember we have to work on it long back, 30 years back. Low cost flow sensors for 5,000 liters tank. So whether to make turbine type has its own advantage. You can make very easily. The ultrasonic is available. For example, ultrasonic flow sensor used also for energy measurements, oil movement measurement, gas movement measurement they used. They are slightly expensive side, but agriculture we seldom use any flow meter. I think this is something has to be thought about. Really can be done easily. Some institute must work on it for flow measurements, because we use water, nutrient, everything. Flow measurement is absolutely must. What is available in industrial is expensive. That accuracy is not required for agriculture. And this is again electromagnetic. Also, flow sensors available. They are available already, but they cost of 15,000-20,000 rupees. Okay. But I think similar ones, some institute wants to work on it. It's possible to bring it to few thousand rupees. So can be used in agriculture. Then you have pressure sensors. Again, MEMS sensor is the latest one, MEMS, very cheap available. They can be used. Now, I have seen MEMS sensor used to measure the tube well, how much water is going down, or open well also, how much water is going down. This also, very less people are working on this sensing of the depth of water. I think TNAU, somebody recently, they told me they are working on this, how to measure the well water level. Must be cheap. In agriculture, must be cheap and reliable. Unless I know how much is the water is available, how will I plan my irrigation schedule? So what is available, if rain is not there, how much available to me? So this is important. Air pressure, all the sensors, you must be aware of it. Then you have speed sensors. These are also very important, because speed sensors to measure the vehicle movement, whatever you call, all the movements you have to measure, Doppler effect, different type of sensors are available in them. You have accelerometer. This is used for animal, for example, movement. I think I had used 2-3 years back, and they use pedometer, gyroscope. These are very cheap. These are very cheap technique. In agriculture, nobody think of using these accelerometers. There are so much. For example, an animal you put on the leg, he knows how much it moves, whether the flea is there or not in that cow. Because if the flea comes, it doesn't milk production goes low. and whether it's in the heat or not, you can find out. So you can find out where all you want to find out acceleration due to gravity, whatever you want, or movement. You can use this very cheap MEMS sensors available, hardly few hundred rupees. Okay. A GPS, all of you know, but very unfortunately, we don't have in all the tractors or prime movers are very used, because when that comes, becomes expensive, and also we don't have a proper policy for this to support it. So we have satellite to measure what is the location. Now, normal what you use in the cell phones, they are about 2.5 meters accuracy. But whereas in agriculture, sub-meter accuracy also up to 5 centimeters are used by RTKS. I mean, there's many guys in India also supplying. For example, laser leveling sensor is using the RTKS. You must understand the principle for this when you want to go for it. This is one of the last slide I'm telling you before discussion. This is about connectivity protocols we have to go. We have to understand how to connect these sensors. I think you should understand the basics of 4 to 20 milliampere, RS-232, RS-485, Ethernet. And RFID is also you're not used in agriculture much, excepting for animal identification. I think for last 2 decades, they're using the cows, banks, when they give loan to buy cows, they put on the ear one tag. So that is the only thing I have seen RFID. But RFID is almost not usable for most of the places in agriculture, which is very much possible to use. So we must get used to the RFID solutions, how we can use. Wireless also very less used in agriculture, where it is really needed, actually, wireless. We'll cover it separately, but I think you must know different protocols are there. We must know the protocol. Otherwise, what happens? If you go to IT guy, you give me, he does not know what we need. For example, he does not know how fast we need the data. He will design a system such a way that he gets 1,000 times the data in a second. We require 1 minute, one data. So we have to explain all those things, and plus the person may not be knowing it. So we understand the different protocols available, and then we explain him this is what we want. You'll get quicker results. For example, this is the diagram that goes 4 to 20 milliamperes. All the instruments, field instruments, oil industry, every industry, using 4 to 20. Because power also going from your main place, wire, and comes back. In this, it's 100% sure it works. Pressure gauges, everything, a flow meter, everything is there. In agriculture, we don't find them actually much. At least in Asia, we're very less people are working on such type of flow meters with 4 to 20, or it can be RS-232. I'm not explaining RS-485. These are all the. Thank you for somebody drawing the diagram. Thank you for that. I think I didn't disable that because I think we are here to learn. I think I will stop the one now. Let's go for questions because we have still time. Today it took time. I think I want to spend time on question and answer. Anybody raise your hand? Yes, Pratik Kumar, I see. You can speak, Pratik Kumar.
Hello, good morning, sir. Sir, my question is that we generally PWM is used in robotics. Why should we use this in agriculture?
PWM is pulse width modulation. Okay.
Yes, sir. We use PWM to control the width of the analog signal. So why should we use this?
I will explain what is PWM. I think pulse width modulation is the frequency is fixed. Okay. And you change the pulse width of the frequency. How many times it's on, how much percentage is off. That is the one, which is very good for controlling the speed of a motor, for example. If it's a DC motor, controlling the brightness of a light, because frequency is same you're sending, but the pulse, how much time in the frequency means one's high, one's low. This is called frequency. Okay. How many times goes high, how many times goes high and low, how many times it goes in a second is called frequency. Now, how much percentage of the time of the frequency? For example, 50 hertz is 20 milliseconds. In 20 milliseconds, 10 millisecond high, 10 millisecond low, that is 50% PWM. If 1 millisecond high, 19 millisecond low, it is 5%. So like that to increase that. So I don't know. Your question is whether analog digital nothing to do with the PWM is output actually. PWM is not the input. Yes, Pratik.
Generally in robotics, I think PWM is used for reducing the width of the analog voltage.
No, you're wrong. You're wrong. I think so let's not ask questions just like that. Okay. Let's not ask questions. You think you use the word and generally use in robot, these are all very complex questions you are talking. I mean, what point questions you have doubt, I'm told you PW is for only for the output, not for the input. Okay. It's recorded so you can verify back again. Anybody
Okay,
else
sir.
has questions you ask? Please go ahead.
Morning, sir.
Yes, go ahead.
Yeah, it is not question. Especially this RFID, no, as you said that. So our university, no, they are using in library for
Yes.
issuing the books, and so ICR has given that technology, and our librarian, no, they are using this RFID for that purpose, and which has smoothened the process, sir. That is there. Just I want to communicate to
Yes,
you.
40 years we are using. I'm working on 40 years with RFID. So, but I think agriculture applications we don't see accepting identification of loaned cows, there or whatever it is. I think agriculture we have to find a lot of use. Uh,
Right.
for example, RFID, I told them to identify the cows which are grazing, how much cow is feeding, for example, at a particular location. This is used in Europe for 40 years, according to me. First time I saw in Europe only automatic feeding cows. So they count automatically how many minutes it was eating, how much minutes it was drinking, then they ban the cow to enter that location.
I
So
think they are mostly these banks, no, who are providing the loans, no, for animal purpose. They are using this technology.
it's a government requirement. It's a
And we
government
should not
requirement
keep
for
up.
30 years. But
And
I'm
we should
looking
not
at,
keep up.
we have to look for other areas.
Oh, yeah, yes, yes.
We are what I know that, but I'm telling agriculture not used other than only loan, giving loan to the cows.
Yes,
We are not using for feeding systems. For example, where it is used for any of the feeding systems, we don't use RFID. I think it's a good area to use it. That was my suggestion.
yes, thank
Anybody else has question, please?
Dr. Syed, this is Naren Shah here.
Yeah, Naren.
So I think we only discussed, during our discussions that RFIDs are used in supply chain. For example,
Yes.
you Bombay, you send something to Kerala, and then you have, on that material, let's say RFID tag, which are fairly cheaper these days, 30 rupees, 20 rupees, 40 rupees, and you have a system.
Still cheaper,
So,
still cheaper.
so that tracking system, one can use RFIDs. Am I correct?
Yeah, track and trace is very good. And I think one of our guys from Mango, he tried track and trace for the mangoes, but it's not completely successful for different reasons. So they're very cheap nowadays. So this one area, track and trace, tracking, all used. Any other questions generally about what you felt, what you want to learn, what you... Any suggestions for the next sessions?
Dr. Syed, I just wanted to compliment, how the way you demystified the whole science of electrical engineering and instrumentation engineering, and how, for example, the users in agriculture engineering, designers as well as application engineers feel afraid of, learning about few things, and the way you demystified. I mean, it's not something mystification. The specialist always mystify us, that
I
this is
know.
the control system you use, and
I know.
so the way you presented, I think the learners, I don't know how many students are there, but they should not be afraid of going into anything. These days you have such a huge resource of, ChatGPT and Google Gemini and all that, and the way you sort of informed and said that, that if you want, let's say, instrumentation, you want to measure certain parameter, don't be sort of afraid of anything. Just go and learn, and then you can question properly with the as a design engineer, or as an assembly engineer, or as a testing engineer. But compliments to you.
Agreed, Naren. The biggest problem is today, younger generation, even IT, they don't know what is the system, how it works. They just go to ChatGPT or, like you told, Gemini, key in what they want and they get what comes from garbage out. They don't understand what they want. You have to ask the correct questions to get the reply. They give only database. They are a big library. All these AI, LLM models are big library. They give you what others have told. That's all. It doesn't create a creativity you have to have. So domain knowledge, why people are afraid. I find all the agriculture, including agriculture engineers, They don't want to touch the area of electrical. And then why they talk about pumps? Why they talk about irrigation? Why they talk about machinery? See, what I want is the engineers who are talking, agriculture engineers working in farm machinery, they know nothing about electronics or electrical systems. That means they never seen any tractor or anything working outside abroad. Then how they will modify here? So that fear we have to remove. That is what I'm trying hard for last 7 years. I think a few students get benefit of it. I think it will
Yes.
continue.
Rajeshwar here.
Yes.
Yeah, I'm very happy. In fact, the learning which I did in college, continuity is never there. So the basics what you have shared today is giving me motivation to continue further learning on how to adopt these electronics into our tractor, agriculture, mechanization, machinery, and all. So fundamentals, refreshing is great, and I'm always motivated whenever you talk on this topic. Very nice of you.
Sir,
Okay.
sir,
Yes.
Sushma here.
Yeah, Sushma.
Sir, just since, sir, thank you very much. First, I will congratulate you and also I compliment you in which way you have presented. And also some of the things, sir, we have forgotten, but today it is came to our mind that those things also we have read, but we are not able to use actually in the field. So since 1 decade, I used to listen that in India or somewhere in agriculture, we are not able to develop the sensors.
I see. I agree, Sushma, because don't try to develop, first use them. See, if
Okay.
you don't know how to use them, how are you going to develop something new? See, most of the people going for soil mulch, they have not tried the soil mulch. For example, I see some universities purchasing 500 soil mulch. I asked the dean, you send me one at least because this, what you purchase will not work. This is about 5 years back. But I think some people show me, like Bisa, I saw it also. And I mean, some places. So technology, you understand first. Don't try to say it come from US, it will work or something, because I think important is what is our needs. So sensors, you can use it. Very seldom people have seen lab people have to use in agriculture universities. They have labs that can demonstrate all the sensors I have told. I think 7 years back, 6 years back, I think Dr. Gajan Singh told me IRI should have one lab. This was proposed, I think 6 years back, but it never came up. I think you should have one big lab of. I will help to come and set it up.
Sir, recently one robotics lab has been inaugurated in agriculture engineering division. So it is a very good.
How many people know about BLDC? What voltage is used? 24 volts, 48 volts. How many people know about it? Starting a center will not help. It's a question of what is your problem. What I say is starting is very simple. You put 2 crores and give a newspaper ad and then take a photograph, it's over. But I think I have seen like this similar, for example, drones. I've seen several universities have a big room for drones. When I went there, asked for, they don't have even soldering station. They don't know how to repair a drone or what are the components of the drone. So just to have a showpiece will not help. So what I suggest is, for example, I'm asking flow sensors. Do you have flow sensors? Do you teach anybody which type of flow sensors is better? Like I told you several types. Flow measurement is very important in agriculture. Why we don't have a lab that has a flow sensor also? One pressure measurements. Like I didn't mention EC, okay, EC and pH measurement. How many of this institute know about EC and pH measurement? The industry people use this to irrigate, to measure the pH. And so I think what is lacking, we know already. We have to, instead of telling they started as a center like this, we should write down the list, the components must be included in that. Then I think, Sushma, we can solve this problem.
Yes, sir. Yes, sir. Yes, sir. Thank you. Thank you.
Yeah, Professor. Yeah.
Yeah, I think you are very right. We need this basic understanding of these things. Okay, so you need, and then application can be developed only, as you said, once you know the use, then you will find out what is lacking or how efficient it is. Until unless you know it's working and what component and what parts do what, and for what we need these measurements. Another thing is, I think for future you might have think the traceability is going to be a big demand, and for all kind of commodities, fruits, big fruits, individual fruit will require a traceability mark, okay, identification tag. On bulk things, it'll be different. So I think keep the traceability requirements for future. Okay.
Yeah, I will.
And excellent, excellent. I don't think at this age I can learn anything, but I'm still enjoying it.
No, no, actually, what I see, I don't want anybody to learn, but then certain important, like for example, today also I didn't tell. Suppose it comes a solar pump, whether you will take a AC pump or you will take a DC pump, because many places they had a problem of DC pump. So this is all I not explain. I'll explain this in the agriculture section. This is only general electrical electronics. I think many parts people don't know. So that's how they make wrong decisions in the top level also to order things in subsidies, whatever they give. And then it goes down to the line. I know several years back, around 15,000 solar pumps were modified in Maharashtra.
Syed, I can tell you, it's easy to get a approval for 1 crore item of
Yeah.
equipment, then 100 rupees small items.
I know. This is a problem. This is actually it is because the knowledge level of the technology from top level is very low down going. So decisions are taken without no. So that's the reason I'm trying students to bring to knowledge a little bit, because they can come. So next generation will be completely different. That is my complete approach, and I will keep on trying that.
I always cite one example. I had difficulty getting a $40 bicycle to go to the experiment fields. Then getting a $5,000 tractor was easy.
Anyway,
Compared to $40, everybody had something to say. Okay.
Okay. Anybody else? Okay. Thank you very much. Tomorrow will be full of programming, little bit of programming and hands-on for the
Is it the
students.
same time? Is it
No,
same time?
tomorrow evening, 7 Indian time,
Okay.
7 p.m.
We'll check.
Tomorrow will be Setu will be joining, and we'll be teaching the basics how to use simple program. Python is very good, simple language. Tomorrow I will explain you how to use it. You will be able to use it if you follow the instructions properly. That's what we want. You practice instead of only listening to others. No, it's difficult. Don't touch it. You try what we say. We are spending our time. Try it tomorrow. You get a laptop ready. Try it what they say at least. Because it's only 1 hour, 1.5 hours. That time you try it, 100% you'll be happy to know that you learned something. That's my request. I would like to thank all of you for being today.
Dr. Syed, very
Please,
quick one.
please. Yes.
How do you encourage more students to join your? I don't see many students here, So I mean, they are really missing, and I thought they are the ones who should really benefit from the fundamentals that you are touching, and both in hardware and software. How do you encourage that?
This most of the students are joining also in YouTube. The last 2 sessions we had. First session we had total more than 800 students I've seen.
Okay.
And the second is YouTube normally, because we say this one, but this time also, because actually this started because from Nepal, the students were very keen. They requested me. And then also Parbani students we included. Then we opened for other students actually. And we also included the Patil Engineering College also, DY Patil ka, because there was a request from one of our friends. So I think it's a basic problem is the professors are not telling the students to learn. The basic problem is they don't know and they think it's not required. And if they know a little bit also,
exposed.
No, I'm very straightforward.
No?
I'm telling very straightforward, because they don't know themselves, so they don't want students to know, because they'll be weaker. Even if they don't repeat, they want to keep it secret with them. So they want to have problem is these are all available in the net, and it may take another 3 months, 6 months, or 1 year maybe, then students will know. But what we give a direction to students. Today, everything is available in the net. But direction, they don't know where to search for. Suppose think about just like a pump, where they will search for, where they will go, what they will do. So the basics are not taught in our universities, and that is the reason we are trying to give some proposal from Professor of Practice, some of the ideas for agriculture. We must work together. So because you see, I have seen a lot of places, agronomists sitting in the projects. They order for pump. They don't know what is 3-phase, single phase. They don't know what is AC, DC. They order the pump. So they can understand from this type of training a little bit. They understand that A points important. This is what I must look for. That is our objective. Our objective is not to make them experts, but that much I think the teaching professors must come. I think they will come. It's a question of keep on banging. I think you will strike one day. I think every drop matters a lot. So I think even 10 people, 5 people learn. It's a big asset. I think I remember in Bombay, I saw when I met you also in the AI4. One fellow came to me. I was not knowing, sir, I have seen all your videos. Thank you very much. I don't know him also. Okay. And he came and recognized my face and told me 5 years, 6 years back our videos. I learned electronics from your videos. That gives a real satisfaction. He's working on electronics now. So I think this will continue. Thank you, Naren. You have been a very strong supporter, all the people. Thanks a lot. Namaste.
Thank you, sir. Yes.